We're going to look at categorical variables. So we can actually attack these with least squares and regression. So you know, if you have something that we maybe have seen before, like you know, maybe we have a gender thing and it could be male, female, something like that. Well, then I think most people would probably quickly come up with something like, you know, here's gender, and you would enter things like 0, 1, 1, 0, and so forth, right? And you know, just 0 is either male or female, and 1 is the other, and you know, that I think it makes sense and not a big deal there, and you do that and you wouldn't really think much about it. But, you know, let's say you had something like color, and that color could be, you know, red, green, and we'll just go with blue, just 3 colors. Well, what you might do is if somebody said, well, let's turn that into a numerical variable, what you might do is something like 0, 1, 2. But the problem with that is that in one sense, as soon as we go to 0, 1, 2, we really are making a distinction in value that's not actually there when you just go with the 0, 1. Because with the 0, 1, you can kind of say, well, it's there or it's not. But as soon as you go to 0, 1, 2, then you know, you could say, well, you know, okay, red is maybe 0, and green is 1, and blue is 2. Well, so, you know, back here with gender, you could say, you know, suppose you had male, female, and then 0 and 1, like that. Well, so here for gender, you can say a 1 means they have the trait of female. 0 means they do not. And when we get into something like slope from the regression, again, it's just the difference of going, you know, of not being female, that would be the male, to being female. What's that difference? You know, what effect does that have? But if we go down here, you say, well, okay, so red is 0. So does that mean it's not green or it's not blue? Well, it's neither. Oh, okay, but it just gets hard to think about that, and this probably sounds like sort of a weird discussion, but it should sound like a weird discussion because it really just doesn't make sense to try to attach a 0, 1, and 2, you know, because does that mean blue is twice as big as green? You know, it just, as soon as I start adding these numbers beyond 0 or 1, it just gets very difficult to try to talk about what that means. Whereas with 0s and 1s, like we have up here, you know, it really is just, okay, the person has the female trait or does not. Okay, and so that makes a lot more sense. So with the color, what we end up doing, you know, if we have these 3 categories or more, and really we're doing the same thing back here, back here with male, female, is just you don't really have to think about it when you do that. So what we're going to do is we're going to choose a base case. And maybe that base case is, we'll go with red. And so now suppose I have some data. Here's color, and okay, this one was red, then we had another red, whoops, red, and you know, then maybe a blue and a green and a red again and a green and a blue and so forth. What we're going to do is we're going to introduce, since there are, and we're going to say base is red, we're going to introduce, since there are 3 categories, we're going to introduce 2 dummy variables, dummy 1 and dummy 2. And we always need 1 fewer dummy variable than we have categories. So if I had 10 categories, I would have 9 dummy variables. And the way this works is our base case of red, we are going to, similar to, I guess you would have called in the gender example, our base case male, because that was a 0. We are going to say that anything red gets a value of 0 for all the dummy variables. Now, dummy 1, maybe that corresponds with green, and dummy 2, that corresponds with blue. And so now for green, you know, green, this one would be a 1 because it is green, and that one is a 0 because it's blue, and a 1 and a 0. And then this blue is 0, 1, and that blue is 0, 1. And so we would go from these categorical values to numerical values of 0s and 1s. But you see now, these don't really take on that value idea of like twice as big or something like that. It just is or it isn't. And so red is the absence of both green and blue. Blue is the absence, or a 0, in green. And of course red was the base case, so it's just absence of both of those. And you know, green, well, green, it has green, but it's absent of blue, so we put a 0 there. And we introduce 2 variables now with values of either 0 or 1. And what happens with that is, if I was just looking at, oh, I don't know, you know, maybe borrowing from the Mario Kart stuff in the book, maybe I'm looking at the price of some particular item. Maybe it's a flower. Maybe red flowers have a certain price, or tend to have a certain price, green, blue, and so forth. So what we would do is we would try to estimate price, and we would have a beta 1 times our dummy 1, and our beta 2 times our dummy 2. And so we would estimate those slopes, and then here we would have our alpha. Well, if these were the only variables we would have, then actually the interesting part here is that alpha is becomes the average price, because again, price is what we're measuring as our response. It's the average price of the red. And then beta 1 actually turns out to be the difference. And let's see, that was green. So it is the average price of the green minus the average price of the red. And so you see what this would say is what happens to the price if we go from red to green? Oh, it will go up by whatever beta is, or go down if the average price of green is lower than red. And then similarly, beta 2 is the average price of blue minus the average price of red. So it's interesting, you know, if you were to give me some data and you were to tell me prices, and you were to say, oh, well, the average P bar, you know, it's like X bar, P bar, and I'll put a R for red, is equal to, I don't know, we'll say 2, and the average price of green is equal to 3, and the average price of blue is equal to, we'll go with 150, then actually it's interesting. If I just know those, I can give the answer to the regression model that quickly. I can say, oh, price is equal to, and here we have our 3 minus 2 times dummy 1 plus 150 minus 2 times dummy 2 plus 2. So actually, you know, it's quite easy to come up with a model. What I don't know is for these values. So here my beta 1 is 1. Here beta 2 is equal to minus 0.5. What I don't know is whether we would consider those betas as being statistically significantly different from 0. Right? That's what we want to know. Are those slopes different from 0? But you see, this is basically then the same question as an analysis of variance for these categorical data. For the red, green, and blue data, we could look at the price. You know, we could order it as, oh, here are the red prices. You know, so if you think of it as columns, let me go to a second page here. You know, if I had red and I had a price 1 and a price 2 and so forth down that way, and a green, and those had a bunch of prices, a price 1, a price 2, and so forth, and a blue, and these prices down there, then that looks like we have something that we would run in an ANOVA, because we have these categorical explanatory variables and numerical response variables. So categorical up here for the explanatory, again here numerical for the response. That would be an analysis of variance like in chapter 4. But it turns out that the regression will do the same thing, and what's nice is we can look at the various slopes and see which ones appear to be different and which ones not. So again, you know, we had a beta 1 that went with the green, we had a beta 2 that went with with the blue. And this one was a 1 the way I had it set up, and this one was a minus 0.5. And suppose what we found was that the p-value here in the green was something like, you know, 0.002. So that's less than 0.05. And suppose here the p-value for this beta, this slope, was 0.064, something like that. Well, then what we would see is that, yes, at least one of these averages was different. The green average appears to be different from the red, but the blue does not appear to be different from the red. Now, does that mean the blue is different from the green or not different from the green? Don't know. Okay, but this least squares analysis here said, hey, at least one of these was different, and it was that that beta, that slope, the green average was different from the red. So actually, we can essentially run an analysis of variance using the regression tools. We just have to do it, if we go back here, with these dummy variables, the 0, 1s, and this is how we fill in those 0, 1s. We choose a base case. Typically, you might choose the base case because is the largest. The most observations were that. So here I had 1, 2, 3 reds, 2 greens, and 2 blues, and so maybe it made sense to choose the red as the base case there. But it doesn't have to be the largest case. If you're doing something like looking at whether somebody smokes or not, often the base case is a non-smoker, and then the dummy variable 1 goes with the fact that they're smoking. You could have categories like small, medium, large. In that case, you might think that, well, why is it so bad to have a numerical variable there? And maybe in some cases it's not a terrible thing. But again, you have to be careful about those numerical variables because, again, if you are going with a small, medium, large, well, is a large twice as big as a medium or something like that? Yeah, see, so you have to be a little careful there. But in those cases, suppose I had small, medium, large, I would probably use the small as the base just because that made sense. So those would be zeros there, a medium, a 1 and a 0, and a 0 and a 1 for the large idea. And, even if the small category wasn't the most, I might use it as the base case just because that maybe made sense to me. All right, so that is this idea of dummy variables and categorical, working with categories in regression. And so if we have a category, we just substitute in those dummy variables and add that to the mix.